Hey everybody, Longo here, and in this video we are going to review function composition. And what we're going to start with is just some evaluating. And I want you to remember that this is, whenever you're evaluating with a number, you should have a number for an answer. And whenever you are evaluating with x, you're usually going to have an expression for an answer, okay? That's just something to keep in mind. Also, remember, there are multiple notations. So f of g of 2 could also be written as f of g of 2. Now, those are the same. When you write it this way, it might help you to understand that what you are doing is you are plugging the value of g of 2 into f. So the first thing you always take care of is the inside. So g of 2, that just means when x is 2, what is g? 0. So what you are actually doing now is you are evaluating f of 0. And then you just go back, look at your chart. If x is 0, f is 4. Done. That's it. Plain and simple. So just evaluate the inside first, and then go substitute that in and find the other one. This is easy enough where you should be able to press pause and go try the next two on your own, so why don't you go give that a shot. Okay, so this one you're doing g of f of 3. So you need to find f of 3 first. So x is 3, what is f? 1. So what you're really doing is plugging that back in there. You're evaluating g of 1. So go find x is 1. What's g? 6. Done. Game over. And the last example, you're doing g of 3. So you're evaluating g twice, and it should be with two different numbers unless g of 3 is equal to 3. So you do the inside g of 3 first. So x is 3, g is 2. So now we're doing g of 2. X is 2, g is 0, so g of 3 is going to end up equaling 0. And that's it. That's how you evaluate from a chart. There are other ways like f of g of 2 where you actually plug numbers into a function, which is something that you have seen before as well. Like I said, this is more of just a little review. So we're going to also review evaluating and stating the domain when we have x to substitute in. Now, special reminder when it comes to domain. You only evaluate domain with what goes on the inside and your final answer. And I will help you with that in just a second. Okay? So what we're going to do here is we're going to take our f of x, g of x, m of x, and n of x, and we're going to do some different compositions. And what goes inside follows. So whenever you're working on this section, on a quiz or a test, it's nice to evaluate the domain for each of the original functions. So remember, x squared plus 2, there are no restrictions, so it's all real numbers. G of x is a square root of x, and remember, any even root has to be greater than or equal to 0. X minus 3, there are no restrictions, so that one's all real numbers. And you also have to remember you can never divide by 0, so n of x has to be not equal to 0. Now those are just your starting domains for each individual function. Next, we have to perform the composition. So this is f of m of x. So this might help if we color coordinate. So what we are going to do is we are going to plug m of x into f of x. So, nice little tip, write out the outside one, but just put parentheses wherever you had an x. So here's an x, all we're going to do is parentheses, squared plus 2. Look, I changed absolutely nothing except for the x alone. And all you do is put parentheses there, and then you take what's going inside and you put it inside the parentheses. And now you just finish evaluating. So remember, whenever you have parentheses squared, you're actually foiling that with itself. So you're doing x minus 3 times x minus 3, which is x squared minus 6x plus 9 plus 2, which is x squared minus 6x plus 11. So now, what is our final domain? So, the domain of m of x is all real numbers. That's what's going inside to begin with. And now you look at your domain of the final answer. X squared minus 6x plus 11. There are no even roots. There are no denominators. So the final answer is also all real numbers. If all real numbers can go into all real numbers, your domain for the final answer is all real numbers. Okay? So you can write it that way, or you've got your negative infinity to positive infinity. So that all depends on what notation you are asked for, and that's it. So we'll do one more together, and then I will let you try the next two. So this one says f of g of x, which again, that is f, and we're plugging g inside of the f. So that means we're going back to that same parentheses squared plus 2 for the f part, and now we're plugging g inside. And now we're just going to evaluate. So whenever you are going to square a square root, it just goes away and you have x plus 2. Okay? So that's your final answer for the evaluating or simplifying part. Next, you have to come up with the domain of your final answer. X plus 2 is all reals. G of x, what goes inside, was originally x is greater than or equal to 0. So, what goes inside and all real numbers, you have to take the final. So, x has to be greater than or equal to 0 because that's what went inside. We were never allowed to plug in a negative to begin with, so we can't throughout this question. Okay, so x has to be greater than or equal to 0 again, or we would have actually square bracket 0, comma, infinity. So that's composition of functions and stating domain. The next two are very similar to what we just talked about, so why don't you pause the video and give it a shot. Okay, so n is our outside one. So we've got n, and we're going to plug m inside of it. So if we were to take our n, which is 1 over x, it's 1 over parentheses, if you like having a place to put things. And then m of x is x minus 3. That goes inside. And honestly, there is nothing you can do to simplify that. So your final answer is 1 over x minus 3. Now your original domain for what went inside, m of x, was all real numbers, but your final answer has a denominator. Remember, you can never have 0 in a denominator, so what we talked about back in the day is you set your denominator not equal to 0 and solve. So x cannot equal 3 is the final. Think of those two together, and your final domain is x cannot equal 3. Okay? Simple. Again, you could do negative infinity to 3 with 3 to infinity, because remember, these parentheses means 3 is not included. All right, last one. We had n of x, which basically should have looked a little bit like this. So we have n going into itself. So if we had 1 over the parentheses, we're just going to put 1 over x back in there. And remember, this is like dividing by a fraction, which means you multiply by the reciprocal, so you just get x. That is your final answer. Basically, we're just doing a reciprocal of a fraction. Done. Now, the original domain for n of x is x cannot equal 0, and x all by itself is all real numbers. So your domain is not all real numbers because what was originally the domain follows along. So your domain is x cannot equal 0. Okay? And that's it. And if it was, you can just use the negative infinity to 0. if you want to use interval notation. All right. So anyway, this is a composition of function review. This is Longo, and I'm out. See you. Bye.